I did work for a number of companies, but not just big companies. If you look at the the life path, it took me from big companies and it took me into startup companies. And I guess moving from a larger corporation into a startup company, you get a sense of the adventure and the unconstrained opportunity that exists when you're in a startup. And part of that you find in Tyndall, right? Because we're not reporting to Wall Street, or we don't have a quarterly reporting. We certainly do have to earn our money. The research services that we sell and the inventions that we make, that's how we fund the place. But you certainly have the art of the possibility in a place like Tyndall, because you're really charting new grounds. Charting new grounds, but not on a, we got a wonderful blue sky day here today, right? Which is actually appropriate because John Tyndall was the first scientist to explain why the sky is blue. But, in Tyndall, I wouldn't characterize us as blue sky research. I would characterize us as really grand challenge or big challenge inspired. That's very linked to an enterprise opportunity, very linked to companies opportunity, very linked to societal challenges. Well, one of the unique things about Tyndall, we have a phrase called atoms to systems. So we do have people in the building who are thinking about electronic theory, and they're thinking at that very, very fundamental level. And it's a very vertically integrated organization, so some of the inventions or the breakthroughs that are made at that very fundamental level, they're quickly grasped by colleagues who are closer to the market, grasped by colleagues who are closer to problem statements that industry partners have. And so we're able to quickly extract those things and move them forward into, let's say, something unique in society, unique that impacts the guy in the street, that the guy in the street can understand. Tyndall, for example, is well known for the work that it did in creating the junctionless transistor. For the person in the street, what does that even mean? But when you're really driving down through Moore's law to higher functionality of electronics, lower cost electronics, the ability to deploy electronics everywhere, the ability to move from connecting humans through their cell phones to connecting machines and things through sensors, that starts to bring it into the guy in the street. And then we can get into doing very fun things. I'll give you a couple of examples, if you will. You think about, let's say, an advanced computer, you think about something that used to sit on the desk. Now think about a farmer's field as a network. Think about wireless sensors that are sitting distributed through that field in various coordinates. They're throwing out information as to the nutrient levels in that soil. That farmer is then able to wake up that morning and realize that field is just doing fine, or I need to schedule some fertilization on that field, and I don't need to blanket cover the field, but I need to cover the areas so that I'm going to maximize, let's say, the pasture output, which is going to maximize the feed, which is going to drive my cattle, which is ultimately going to drive the whole agricultural food chain. I mean, where do people wake up and think microelectronics in my field? But if you were at the plowing championship in Rafinesque just 2 weeks ago, there was a very big buzz around such an exhibit from Tyndall. And when I look at Ireland, we've got a lot of really bright spots on the landscape and very, I think, highly functional, high-level, specific institutes and research centers. I think the key for us is join the dots. I mean, I give you that example of wireless sensor networks in the field. I mean, our piece of that is hardware. We can tell you what the phosphorus content is in a particular part of the field on the soil, but that in and of itself is useless. I need to be able to throw that data up, and I need to be able to catch that data and do analytics on that data, and I need to act on the data. And so that's someone that isn't me. So we partner very strongly with TSSG at Waterford Institute of Technology. Great example. We'll take care of the hardware, they take care of the software. Again, now we've generated, data, we've analyzed it, we have to action that data. Someone needs to be able to action that data, and that's when you get to the third partner in this case, Teagasc, National Institute for Food and Agriculture. When you start connecting the dots, you create something very powerful. You create something powerful that doesn't exist maybe outside, but something exportable. We have, of our native economy, let's say our non-FDI economy, agriculture is the biggest piece of that. That's something we can export worldwide.